Very good. So, good morning, everyone. How are you today? Right? Hey, I'm really excited to introduce the first keynote of this conference. And it was fun to see ICSA introduce the history of these conference series. But you forgot one part, ICSA. There were the International Software Architecture Workshops at ICSA in the mid-90s that led up to the ICSA conference. And I realized, as ICSA was going through this, I've been part of this community for close to 25 years, which for me is a really long time and actually makes me feel a little old, I must admit. But what have I learned over those last 25 years working on software architecture? Well, what I've learned is that really real work and interesting work on software architecture does not happen in academia. Sorry to disappoint 2/3 of the audience, but real interesting work on software architecture actually happens in industry. And if you look over what has happened over the last 10 years or so, you can see that the industries that have had the most interesting developments in software architecture have been the internet or software as a service companies. That's where you've seen the hypergrowth. And although many companies, many people, when they think about internet companies and software as a service companies, they talk about companies like Google and Facebook. Actually, one of the most successful internet companies is Booking.com. And that's why I'm really excited to introduce the CTO of Booking.com here this morning as the first keynote speaker. Just to give you a feel, Brendan joined Booking in 2008. And at that point, he had 36 engineers working for him, and I think you guys are running a handful of servers or something along those lines. Today, under his leadership, this company has 1,600 engineers working for them and is running tens of thousands of servers, and that's what Brandon is going to be talking about today. I've worked with Booking since 2012, actually, so for the last 5 years. And what I've noticed is that Booking actually takes an approach to architecture that is different from what we think is the commonly held truth. For once, they do not have architects in the company. Yeah, so what you see is that they say either everyone is an architect or we don't have architects. You choose whatever you prefer as a motto, which I think is an interesting one. The other interesting thing is that when a company like Booking hits hypergrowth, everything is about scale. The only thing that matters is how does your IT infrastructure, how does your product, how does your services support the growth in the business, and everything else is secondary. We were having breakfast yesterday morning before we had a session with a few Swedish internet companies. And Brendan told me that a few years ago, he hired an engineering director. And when that engineering director, after a few weeks on the job, identified a huge inefficiency that he wanted to put some R&D resources on, because he could see that this could save the company around €1 million in cost. The response from Brendan was, please go work on something important. Yeah, so that's the kind of focus that we have in a company like this that works on scale. So over the years, I've heard I think, great story about the Booking.com software architecture, and I'm really excited that we today have a chance and that Brendan has agreed to share this story with the ICSA community. So please, with that, join me in welcoming Brendan Bank.
Dankjewel. So, good morning. Clicker. I'm Brendan Banks, CTO of Booking.com. Like Jan said, I've been in this role for 8 years, and it's been a very, very interesting ride. From a small company that I joined 8.5 years ago, like Jan said, 1,300 people, we had to go through these enormous scaling exercises to scale not just the infrastructure, but also the people side of things. And to grow from 30 to 1,600 now requires a lot of time and attention to make sure that everybody's focused on the right things. Over the last, we were founded in 1997 by Geert-Jan Bruinsma. And over the last 20 years or so, we had some interesting iterations. So Geert-Jan started out with an Access database on Windows, put some scripting on top of it, and it kept on crashing over and over again. It was a simple website, and the way we interacted at that time with hotels was really to call hotels for, hey, do you have availability? We put it on the website. Many hotels didn't have any internet connections. And then when we had a reservation from a guest, we often called the hotel, do you have availability? And yes, then we called the guest and said, yeah, you can stay at the hotel. So it was very manual. Until what Jan was talking about was actually Bo, who's here with me. We would be able to save cost for about $1 million in fax cost. So we were faxing until 4 years ago millions and millions of faxes a day to hotels, because this was the way that we communicate with hotels, and hotels prefer that method. So we complied, and instead of email, we sent them faxes. So you have to deal with an industry which is not very adaptable to change and not very adaptable to technology. They're very good in hospitality, but they're not so good at marketing and technology. So you see here the office of Geert-Jan Bruinsma in Amsterdam. Again, he started out by himself, and until 2001, the company kind of grew organically, slowly. This was also the adaptation of hotels. Of technology is low, internet adoption was low, and there was still a lot of friction in the system. Then one of the major inflection points was Google, actually. They came out with AdWords in 2004, and now suddenly we could buy qualified traffic. Before this was an absolute jungle of SEO marketing, and anybody, and maybe some of you remember, you could buy tens of millions of clicks with totally unqualified traffic, with people that were not looking for a hotel, but they landed on your website, and we had to pay for it. But now we could buy qualified traffic, and this was massive, because now suddenly we could target an audience that was actually looking for a hotel, and this was and Booking.com took off, but there was a major problem. The time to book, between the time of booking and the time of staying of a guest, depending on the type of booking, it's about 30 days. So you pay 30 days in advance, and you get your money 30 days after the booking from the hotel. So there was this 2 months valley of death, and after the fourth mortgage of the existing owners, they were like, okay, we need some help. So we were bought by Priceline. Priceline.com is a large travel company in the US. And over time, they've helped us grow to what is now the industry leader in selling online accommodations, and we're Google's largest customer. So things went very well, and we're now about 16,000 people in Booking.com. So this is in 2006. It's about 100 people. And our mission, and it will become apparent why this is important, was to help leisure business and business travelers, whatever their budgets, easily discover, book, and enjoy the world's best places to stay. So very clearly, we had one mission, and that was accommodations. No flights, no cars, no transportation. And the travel industry is very, very large. Hotels are by far the largest portion of that. And to focus on that, and we had a very small market share, we had a business model that seemed to work, so let's execute that as best as we can. Booking.com doesn't have really the best business model. nor does it have the best technology or the best marketing. But what it does have is enormous amounts of operational excellence. So when we do something, we do it very well, and we do it very focused. So this resulted in this is the BAM booking annual meeting in January in Amsterdam. There was about 7,000 people, and we had an all hands where we basically set this new mission. And I'll talk in the end a little bit of why this is so important for me. So to empower people to experience the world. So now you see suddenly that we're not only focusing on accommodations, but we're going into a much wider field where we want to help people throughout the whole journey while traveling. So some key figures just to set the stage a little bit. Currently, this is from what we can report. So that's the fourth quarter 2016. Over 1 million active properties on our website. I'm doing it the other way around from you. So 24 million rooms, about 1.2 million room nights booked every day. Of course, 2 out of 5 are mobile. Over 180 offices. Booking.com is local in over 40 languages. This is key to our strategy. Booking.com must feel like a local website everywhere. So, for instance, in the Middle East, we put a lot of effort in making that work in Arabic, which for us from Amsterdam is of course quite a problem because of the script. So we hired a lot of people from all over the world. Tech currently is over 80 nationalities, so we have 80 nationalities in Amsterdam to make sure that all these sites are actually correctly native in speak, but also in usage, because we see small differences between markets on how people use Booking.com. We have over 100 million guest reviews. This has 13,000 staff. It grows fast, and we're part of the Priceline group. Now, when Jan told me to tell something about architecture, I was like, I was a little bit unsure for an audience like this, because our architecture is pretty organic and driven by scale, and not so much driven by a theory or anything else. So, but we have this, and this is a graph of the amount of travelers that are traveling since 1995, and what you can see that is growing extremely quickly. And the reason for this is that poverty is getting eradicated very quickly right now. So people move into a middle class, and what do people do when they go into middle class? They want to experience, they want to travel, and that's what you see here. So basically, from 2013 onwards to what we think 2030, the amount of travelers will double. So we're absolutely in the right industry if you look at this graph. And then on top of that, why do we do so well? Because we have this, and this is one of our cultural statements. We put the customer at the center of everything we do. Basically what we are like Uber, we are a two-sided marketplace where we have supply and demand and a shop in the middle. And we focus entirely on the customer. Of course, this is always interesting when I do all hands or new hires meetings, when people say, but we are an agent, so we are an agency, so the hotel actually pays us a part of their revenue, so wouldn't you consider them a customer? And we said, no, we focus on that person that books, because they have the requirements. And for a hotel to do online marketing is very difficult. So if you are a little hotel in Austria in a ski resort, and you want to market your property to a South Korean, and they love skiing, then for you, as a hotel, it's extremely difficult to do that. And we can do that very easily because we have the knowledge and the systems to help you. So we can do it much more efficiently. So we are a marketing partner of the hotel, but we really, really focus on the customer. We think it's our customer that we bring to the hotel. And this focus is key in our thinking because hotels come up with all kinds of products that our customers do not want. So we have to make sure that we keep them in line. So most importantly, keep the customer of the center of everything you do. And if you follow the customer, you cannot go wrong. But then from a technology perspective, we have some really, really interesting challenges. Like I said, we started, I think my first server order was 60 servers, and everybody was up in arms because that was a significant amount of money that we were investing over, I think over 400,000 euros, and you know, I had to go all the way to Priceline to get that signed off. But we were a very, very small company. Now we have indeed tens of thousands of servers, basically our own internal cloud, and to manage that and how that's evolved. There's a couple of principles that we apply. First of all, be pragmatic, and I think the story of the faxes where we could save 1 million, but that work to save that 1 million will distract us from focusing on our customers and building better product for our customers. And the interesting thing is that if I use the same amount of time to focus on customers, I can probably make 10x compared to that 1 million. So for me, that 1 million, and when you come and work for us one day maybe, then you will find that there's 1,000 things that are not working right at Booking.com. And that's okay. We accept that. We accept that breakage because we focus really entirely on the customer. And when and by doing that, we accelerate our growth. So really pragmatic approach to architecture, minimizing the opportunity cost of things that are of no value to our customers. Build a culture of, I say culture of failing, but I can't say that anymore, so I'll say culture of learning. So, you know, we can only learn. There's a totally no blame culture. And I will show you some of our spectacular crashes of our systems later on. And last but not least, be data driven. I'm very happy to see that even this conference is data driven. I'm very sad to see that's only 14% women. We're actively trying to change that. I hope that you are also actively trying to change that, because it's a shame, and it's that the industry is that females are so underrepresented in the industry, and I think we have to work much harder than displaying numbers. It starts there, but we need to actively get more women in the industry. Now let me go into the pragmatic approach, how we scale our architecture. So I already gave you our first architecture was an Access database with some VB scripting on top of it, which crashed. And then somebody handed Geert-Jan a book about Perl, and he started programming in Perl, and we still use Perl today. We have over 10 million lines of code in Perl, and it works great. There are some downsides to Perl, of course. Would I make the same decision today? No, of course not. But we built a company over 80 billion, worth over $80 billion based on Perl, and you know, so we have to live with it. And it was a very good technical decision at the time. It still helps us a lot in velocity. There are some downsides, but you can overcome them. Pragmatic and minimize opportunity cost. So again, this very simple architecture, a database in the middle, a website where you process the booking and you show the availability to your guests, XML interfaces and APIs to your partners, and this is how it worked. And this is what we call Bookings 2. It started out in 2002. by 2 engineers and a extranet for our partners. And this was happily zoomed on one database, and it worked great, and we were able to grow exponentially, and we were growing 200-300% in those days per quarter, mind you. So it was really this hyper growth kind of started. Now then, next was a real big issue because, of course, this database was optimized for writes and not for reads. So then, there's they compete for resources in the system, and we split off the reads and the writes by moving to a master-slave configuration. And this in itself is already kind of questionable if you look at it probably from a theoretical perspective, because what you also could have done is split off functionality, put them nicely into services. I think that concept was coming up at the time, and have a service bus but we didn't, and the reason was really because that is very dangerous in a situation where you are under-resourced and have a lot of growth. Because these were agile teams. Well, you can't even call it agile. Everybody was reporting to the CEO at the time, so it was about 15 engineers. Everybody was reporting to the CEO. There was no real structure. Everybody was working towards the same goals, and it was working great, but there was a lot of there was no documentation of functionality. There was no, everything was in the code because everything had to go quickly. There was little documentation even in the code. So to split a part of the functionality off into something else will probably get you into a bug bingo situation for months, which will then slow you down. So, by doing this, by splitting the reads and writes, we were able to easily scale without having all the downsides of having to refactor code. And until recently, refactoring was almost like a dirty word in Booking.com, because the thought behind refactoring is very understandable and good, but the ROI of refactoring is very unknown. And since we're data-driven and we want to understand what the ROI of certain work is, it's very hard to determine the ROI of refactoring. There's always the promise of code being more efficient and new changes being rolled out easier, but it's always after the fact. It's really and it's very hard to calculate that upfront. I now have some people that do that, but I trust them, but it is always in close collaboration, because what we also don't know, if everybody starts to refactor, it's very hard to control a very autonomous workforce. I'll get into that in a minute. Okay, so it got out of hand, and searches in Italy took 20 seconds. Things really got to a point where the website became pretty unusable in certain markets: Rome, Paris, New York, where we have lots of properties. Calculation of prices is a very, very complex computation. So we split off all the tables. So this is really a table split between availability and inventory and the rest of the databases. So basically, now we had 2 databases, a whole replication chain. And then, but from a software perspective, it still looked like one data layer, because there were lots of constraints, but and we didn't have any foreign constraints in the database, luckily, because otherwise we could have never done this. But so in software, we kind of joined things and tables together, which was, again, not, if you look at it from now, you're like, why did they ever do that? But it was it was a very pragmatic approach, and it helped us, again, grow and not be distracted from our mission. We had some more interfaces that we added. We also split the book process for security reasons. So This was HTTPS and in a secure environment, which was highly protected because we also take the credit card information. And then in 2012, we introduced something like materialization, which you see here in the flat AV box. Because these searches again for these large areas or maybe an entire country and you were looking for a villa with a pool, then it would basically time out. So we materialized our inventory so we could search for it very quickly. And we again built replicas and again, good pragmatic decision, which saved us a few years. And then in 2015, we had more materialization and more replicas, and more. We have a XY API, so we now had the first actually service in our architecture. Now, of course, we could have come up with this in 2002, and I think we could have architected it like this. But remember that what you see here, the FAV, so the flat AV, that's 3 clusters of 128 servers, just to in one data center. So that's just to provide all the front ends and all the data analytics teams and all the external partners with up-to-date inventory data. And this would be way too expensive. Now, it's the right architecture for at the time, and it's already evolved from here. But if we would have built this from the start, we would have been bankrupt. So you have to kind of do what you got, and we got this foundation of that 1 BP database, which we still have, but then split it and grow it gradually, which is financially a very good, solid process to do. But it has its downsides, that you now end up with an architecture that is designed for one thing only, and that is scale. So that's pragmatic approach to how we grew into what we are today. The next thing is build a culture of learning, and I'll give you this bash script. Basically, what this piece of code does, it looks for a process, and it will basically kill that process on a Linux server. And the change that was made was that what you see here is that here we grab it and then pipe it through awk, and here we pipe the whole process list into awk, look for that environment daemon, print it, and then that's procs, and then you see if it's here, if it has a value. If it has, then kill it, sleep, and then see if it's still there. And then kill it again if it's still there. And even kill me -9. So we forgot one thing. We forgot to export the value from the script into an environment variable of AWK. So basically it matched everything, and it started to kill random processes on a server. This is fun. Right? This is Chaos Monkey. This is your Chaos Monkey script. Try it, it works great. But it's a little bit problematic if you do this on 20,000 servers. So this was rolled out by Puppet to 20,000 servers, and suddenly we get a call, there's some really strange things going on. And it started, and this run like every 5 minutes, so it started killing random processes on servers. To the point where everybody was like, oh my God, what's happening? And it took actually some time to figure out what's happening. So everything that we do is if it can go wrong, it will go wrong. Just by the sheer amount of infrastructure we have, things will go wrong. And you have to cater for that. And you can't cater for that so much in systems because, mind you, all our communication systems, all our monitoring systems were knocked out by this script. So we were basically blind, and it was very difficult to assess what was going on. SSHD was also killed, on many servers. So we could still, the only access to a server was an out-of-bound ILO access to the console. But we cater for this. And how do we cater for this? So things will go wrong, they will go terribly wrong, but we measure it, how much times it goes wrong. And and what you see here is the amount of lost booked commissions. So we get commission from hotels, and we can predict very well over the day how much bookings we should take. And if we have an outage, then we can say how much bookings we lost, and then we have a measure for how much commission we lost, and we measure that. Because the idea is that we want to go as fast as possible to build customer value, but we don't want to be risk adverse. And one of the biggest issue with engineers is they want to build beautiful things, and they want to build things that don't fail, because they don't want git blame. Hey, what were you thinking? So they're very risk adverse. So by having this red line, I have actually a budget for outages. And the way that this works is, let's say 100,000 euros a month. That's not the real number, but anything that is under, if we're under for a month, then I ask myself, are we getting too risk adverse? And then when I'm over, what is going on with process, culture, or systems? And it's more like it's a health check. But this is real money, right? I have to negotiate with the CEO, what will be the outage budget for next year, and how can we improve it, and how can we not become too risk adverse. So the outage, the Chaos Monkey outage is actually this outage, and we were up in 3 hours. Because we are so used to things going wrong, it happens almost daily, that all our crews and teams are trained towards fixing it very quickly. And they have tools and systems, although they were knocked out, most of them in this case. We were able to create a fix, deploy it, and then started rebooting manually, sadly, 20,000 servers. So that was no fun, but we were able to do it in a very short time frame. So this could have knocked us out for days. It actually, our first customers were back up in 2 hours. Full site was up in 3. Now, when this happens, this is like a 2-3 year event. We sit down, we do an RFO, and we look at every single aspect of this failure, because one guy making an innocent mistake like this, right, cannot have an effect like this. That's not just, and that's not his fault. It's just because it's always a process, and it's a chain of events that happened that led up to this. And so you can't blame the guy for checking this in, because his testing procedures were not good enough. Because they should have called this. We should have never rolled it out to 20,000 servers in 30 minutes. So all those safeguards were not in, and so this is an exercise in looking at our monitoring infrastructure, looking at our orchestration architecture. Is this actually, what is going on and how can we improve it? And for an audience like 10 times bigger than this, I said, and the guy is called Anastasios. I think he helped us a lot in making the website better, right? He caused a huge outage, and but he did help us, and that's why a culture of learning or failure is so important for us to build the next level system architecture. So here I had serious discussions with product development. So because their velocity was also a little lower, so I was like, okay, what's going on? You know, are we aggressive enough? If Mario Andretti said, you know, if you get comfortable, you're not going fast enough. And for us, we don't have competition really. We have Expedia in the US, and we have some local competition in the rest of the world. But we are by far the largest OTA. So for us, it's you know, we only have ourselves. And if we're not paranoid, we will slow down, and then somebody else will eat our lunch. So this is also a measure of, you know, how risk adverse or risk taking we are. Now, be data driven. This is a little bit of a catch, but the most important thing is this guy Hippo is the highest paid person's opinion. This is the biggest problem to be data driven. And many companies are very successful being opinion-driven and doing opinion-driven data development. In our culture, that's, you know, it's just not happening. It leads to two things. It leads to, you know, very informed decisions, but it could also lead to data paralysis. And what I mean with that is there's no data in our company, we are stuck, right? And we have endless debates because if there's no data, but we have to take a decision, then so that's the downside of it. But I rather have a culture of, you know, being data driven than a culture of being opinionated. And you know, no hippos is so no highest paid person's opinions in your decision making process is super important. If a junior data scientist comes to me with very solid data analysis about why we should do something, then, you know, we should do that. And if somebody very senior comes to me and says, hey, you know, let's change the website here because I don't like the fact that, you know, it's too busy and it's, you know, doesn't feel right, then we ignore that. To the point where our former CEO slightly wanted to change the mission of Booking.com, and that never made it to the top of the backlog of the team because there was no ROI in changing that mission, so why should you do it? So we do, as leadership team at Booking.com, have a couple of Hippo cards a year that we can pull to say, okay, now you will do this, period. But we try to use them as little as possible because those are really difficult in our culture, and you immediately get questions. Well, you know, this is not how we work, and you know, engineers are very vocal, so you get a lot of noise. But you know, no hippos is very important for us. Relentless testing. So what you see here is two versions of our mobile app. You see here the prices on the left. Here you see the prices in the middle. We show that we split our users in two, our traffic in two. We give we expose this to 50% on base, and then the variant we expose to another user group, and then at the end of the day we have a very nice metric, and that's the booking. We look at how many people book more, and we do thousands of experiments like this every day and this will help us make decisions. It's a nightmare for designers, especially when they come, because they want to build beautiful websites and, you know, beautiful buttons, and then you test them in an environment like this, and then the customers don't like it. There's a very famous blog post. So maybe people know we have the hamburger icon, which is that icon with the 3 stripes in all the that is now in most apps, and you click it and then you get a menu. You know, it's been talked about the new designer language and all that kind of stuff. We did a test. So we did a test of 3 stripes and just, you know, a small square which says menu, and our customers, you know, don't mind. It was a neutral experiment. So it doesn't matter if you put that new design language that everybody raving about or just menu. It has the same effect. Again, this also leads to side effects that are very difficult to overcome, like data paralysis. And doing so, we have a product, and it's a very simple product. It is, it is 5 web pages, and it's been out there for almost 15 years. So it's not very complex from that perspective. But for us to do something entirely new from 0 to 1, this way is very difficult. So you need to have new processes to build and innovate from the start. Things like what Google X has done to foster that really 0 to 1 innovation, as we call it. But for us, where we own a very tiny piece of the market still, and there's a blue ocean for us to capture, this is a great way of iterating ourselves into success. Now, from a team perspective, and this leads up to architecture, so bear with me for a minute, is we want data-driven product development, and we want high velocity. And we optimize for speed and quality. We do not optimize for efficiency. We grow ourselves efficient. And the way that works is if your cost base grows slower than your revenue, then you become efficient. So you want to grow yourself efficient. And that's not to say that we're not frugal. We are, and because we understand very well that you can only spend €1 once. But in principle, we want to go as fast as possible. And the way we've done that is we created a management structure where the pyramid is upside down. We give the teams a strategy and a great working environment where people really feel at home, not as some other companies do, where you have 16 restaurants and really create an environment where everything is possible. So we're still frugal, but in terms of strategy and working environment, we give the teams pretty much freedom, and there's now over 200 teams, pretty much freedom of what they want to work on. Each team is clustered. They have a strategy. They have sub-strategies of that strategies, and they have very clear KPIs which they optimize for. And then we have myself and chief product officer, middle management, and then autonomous teams. And what we get in return is impediments and hopefully results. The impediments we need to take out, but then the teams can really pretty much operate on their own, because these missions are very and these teams have very set goals, and we try to and that's a lot of work. We try to make sure there's as little dependencies between teams as possible. These teams can pretty much venture on their own. The downside is that there was a cookie tracking system which was not really working well, and then 2 teams started to develop their own cookie tracking system. But that's okay, right? We have duplication of efforts, but if we want, the cost of synchronization of those efforts is often much higher than just leaving those 2 tracks going side by side. The other point is, because we experiment everything, you will find that if you do that a very large portion of all the things you're doing does not bring customer value, so you throw them away. So the chances that something actually gets customer traction is very low. So don't worry too much about that duplication of effort, because the chances that actually you have 2 teams building 2 fully fledged cookie tracking systems is very small, because one of them will fail in the process, because customer customer behavior is one of the hardest things to predict. And if I do a test with you after 4 experiments, usually 1 or 2 people have all 4 rights. So it's very difficult to understand why. If you look at this picture, Y is a price on the left, less converting than a price in the middle. I don't know. That's A/B experimentation will not tell me the why. It just tell me that it is. And then we do user testing, which is more qualitative testing, to understand the why. But this is how it works. And then the biggest thing is because we have so much data and we feed all this data into the teams, they can optimize for these metrics themselves. And this allows them to basically venture off and really optimize the product by themselves without much oversight of the rest of the organization. So this is what data brings to organizations. And that's why our data infrastructure is very elaborate. I can tell you almost between in 100% what my booking rate is now, and if it deviates from the predicted rate and why. And in our deployment infrastructure is also totally geared to this because it's continuous deployment, of course, but our rollout and rollback mechanisms are very elaborate because if something goes wrong, it goes wrong, usually very spectacularly, and we need to have a red button which allows us to roll it back very quickly to minimize the impact on our customers. And the fact that we have that red button means that we can take a lot of risk high up in the infrastructure. So most of our code is untested before it's tested by our customers, and within seconds we can see if something goes wrong, and we can roll that code back or turn it off and make sure that things have a different code path. Again, if we had a very elaborate testing infrastructure, that will take time, and since most of the changes that we make in our product are actually not working, you don't want to spend too much time on testing because it will slow you down. And since the success percentage is a pretty fixed percentage, the more experiments I do, the more successful I am. So everything is geared towards velocity. Again, it's a trade-off, and we have systems where we absolutely do not do this, and we have very elaborate unit testing, but most of the things we do, we just roll out to production, and we have orchestration systems that automatically roll back parts of our code if they see large dips in certain KPIs. Again, all possible because this constant flow of data from our guests and users towards the teams. So, just want to leave you with 2 thoughts. First of all, back to if you want to scale, if you're in a hyper-growth environment and you are resource constrained, then you really need to be very pragmatic with your architecture. And I think the database and sharding example and the materialization example kind of showed that a little bit. Engineers are very creative people. They model the real world into an application or an architecture, and it's a very creative process, just as creative as a designer. So you need to give them almost absolute freedom to do their job, and give them context, give them strategy, and let them do their thing in the structure of autonomous teams. Again, there are many situations where that may not apply. This applies for Booking and some other companies, but we have found this work very well if you are in this high growth environment, and be absolutely data driven. It has some downsides, as I explained, but most of the time it will save you from making the wrong decisions. And I jokingly say we fail ourselves to success because the amount of failures is far outseeds the amount of successes, but all those failures do not make it to our customers. And this is how we are successful. Now, of course, at the start I showed you that the mission has changed. So for the first time in 15 years, our mission is updated significantly. And this means something for me and my team. And it means something very structurally, because Booking.com is basically, we have services, don't worry, but it's basically a big monolith, and it's working very well, and we're very happy with it. But something has changed, and the fact is our mission has changed. And the core of Booking.com is basically an inventory database, which you can ask, hey, from this date to this date, I want to find a room or an apartment in region X. But if you want to book a restaurant, or you want to book a flight, or you want to book a car, or you want to book an attraction like a concert or a museum, then that doesn't work so great. The monolithic code base has a lot of advantages that you can act really, really quickly, and if you want to date, there's one place you can get that date, but in the future that will not work so well. So we're now transitioning from a very successful, high growth, monolithic code base, only optimized for extreme scale, to a more service-oriented architecture, where we allow more freedom for teams to knock up new applications and new services. But this is sparked only by the fact that the mission of the company is changing, and that we're broadening our scope to a wider set of customer products, and also partner products that we need to cater. So again, if I would build Booking.com today, I would probably not build data centers. I would go to Google or to Amazon. I put it in the cloud. I would not use my own databases. I would not even probably use relational databases. But those were all trade-offs that we made in the past, and they worked out really well. I think for us, it's a little the foundations where we started were very good, and we build on top of it. Of course, with today's knowledge, and today's infrastructure that you can, as a service, you would make different trade-offs. But the trade-offs we made, paid off really well. So, thank you for your time, and give it to Jan.
I need a student volunteer, actually, who can carry around the microphone, because we're recording this and streaming, but we have a few minutes for questions. So I was wondering if there was a question. There's one in the middle. If we start, why don't you speak, and then I'll repeat the question.
Thanks for your interesting presentation. I am curious about your... Yes, thank you. I'm curious about your release management and your deployment style, or releasing new functionalities, in the sense that you have a lot of engineers who are releasing a lot of code. Does the architecture support a kind of automatic diagnosis of what kind of code caused the problem or an outage, and the way to roll it back?
Kind of. Okay. So the way the release process works is everybody commits code into trunk, then we release trunk. Depending on the app, in total we release like 60 times a day, but that's across many different applications. But everybody puts their experiments in trunk and then starts to switch them on through a tool. The tool will, there is some detection in the tool if a certain experiment goes sour. So if we see bookings drop dramatically, or if we see page load time going up dramatically, or we see a lot more SQL queries in a certain experiment, then alerts will go off, and people will start to notice and turn off that experiment. So so basically your code will be rolled out if it compiles.
Yes, but how do you know which code caused
Because the experiment is in an experiment, certain code is actually gold. So if that experiment goes sour, then we know that it's roughly in that area of code that things go wrong.
Okay, thank you.
There was a question in the back over there, but yes.
Thank you. It's related actually to the first question. The autonomous teams, you said that they get back feedback in form of data. So what kind of data do they get? Do they have the access? Can they do their own data analysis on the kind of ground truth, or do they get already processed results from the analyst? And together with this, do you have one analyst per team, or?
Okay, yeah, good questions. We have an experiment tool, which basically aggregates this data and then aggregates per experiment, and then puts some basic analysis on it, and that's real time. So, and we measure things like CPU time, memory consumption, user time, conversion, cancellations, all kinds of business and technical metrics, baseload time, SQL queries. Those you can measure pretty much real time. We present them in the tool. If they want further analysis on a slightly, so we have teams and then we have tracks, and a track is a collection of teams. We have data scientists in every track to do further analysis on if they want to go deeper, or they can even go down to the raw events. So they can trigger, we have basically an event stream, and they can trigger in that event stream certain events that they want to collect. So they can go down to the raw data level if they want to. So we give them a very elaborate set of tools where they can go deep. So I think that answers the
Pretty much, thanks.
Yeah, thank you.
Other questions? Here in the front, and we need to start wrapping up, so there are 2 more questions, and then I will have the honor of having the last question.
Well, first, thank you for the very nice presentation. One question that I have is that the idea of collective ownership of your architecture is a very nice idea, but I still saw some snapshots of how your architecture evolved. I'm curious about what was the decision-making process for that? I mean, it's difficult enough to get 5 people to agree on an architecture. I imagine thousands of people, it's nearly impossible.
Yeah.
Who was driving that? I mean, what was the decision-making process there?
Yeah. So the first decision to split reads and writes, company was relatively small at that time, and we had 2 DBAs. And they asked, they went to MySQL and say, do you have a consultant? A consultant came and they discussed. So then there's 3 people, so that was easy. In that case, those decisions are made within that team. You can even scale that to today's world. We have a data team that is responsible for databases, Cassandra, Hadoop, etc. And there are very senior people in there that look at, okay, where do we need to go to grow to what we call next season's peak? And we we have a very strong seasonality due to the fact that most people live in the northern hemisphere, and they all tend to go on holiday at the same time. So our peaks are currently now and leading up to early July as the biggest day. So they make calculations. Okay, can the infrastructure survive that peak? But the responsibility is in that team. Now, of course, they take input from other engineers, but the responsibility for making those decisions is confined to a small set of people, and we have distinguished engineers that have done this before, that have done these cycles before, and they help these teams making the right decision. That's as close to an architect as you can get, but they still are responsible for other areas, and so the ownership is pushed down low into the organization. It doesn't mean that everybody can decide on all on every element of the architecture.
So and then Patricia has the last
Thank you.
question.
Patricia Lago from the University of Amsterdam. You have this aggressive approach to experimentation. I guess you want to be fast in that as well. And you want to learn also a lot. So do you have a way to, or better, how do you design and perform all these experiments faster and more effectively?
Yeah, it was easy when it was a small team, but we now have 3 teams that run the experiment tool, but they also educate the teams on how to run proper experiments. Our biggest problem is you can throw shit at the wall, see what sticks, but that's not the way to do experiments. You need to do it the scientific way. You need to have a good hypothesis. You have to predict the outcome, and then see why the outcome is maybe the same or different from what you're measuring, and that way you learn. So we do a lot of training onto teams. We do a lot of, and the tool actually drives you towards that, because you have to set goals up front. You have to write down a good hypothesis. More than once, your hypothesis will be checked, and people from the experiment tool team will come to you and say, "Are you really doing this? Is this really what you want?" Because it doesn't make any sense. So we're trying to educate people. The biggest problem is also to educate the product organization to make sure that they are very data-driven. They understand data. Basically, they need to be data analyst level, sometimes even data scientist level, to really understand what they're doing. So lots of education, lots of training. I have about 20 people responsible for training and development to make sure that this way of thinking and this culture is implemented throughout the organization.
And with that, I want to thank Brandon for his talk one more time. We have a small token of appreciation.
Thank you.
Thank you. It was wonderful. And with that, we break for coffee, if I'm not mistaken. So we'll continue at 10:30.
Questo... no.